The objective of this demonstration is to show code blocks debugging. What we'll want to do is set up our example 2_14. We'll want to put that into another window. So we'll call this program 2_14. And then we'll copy the file 2_14 into there. Now there are probably other ways to do this, but I'm going to show you one, and if you can find a better one, please do that instead. So if you right mouse click, we'll open this up. It opens up code blocks as we've seen before. Again, we'll get rid of the tips, and then we'll see that 2_14 is showing up here. The next thing to do is open a project as we've done in the past. So File, New, Project. We want a console project. We'll go ahead and continue with next. We'll take C++ and we'll call this program 2_14. Now we're going to line up the folder with the folder that we've already got. We don't want to go down to program 2_14 because that will already be included. I'll show you that in a second. So we'll just select source code, press OK. Now we'll want to examine these paths here. So this is code blocks, chapter 2, source code. Okay, and that's good. And that follows this that we see in the Windows Explorer, code blocks, chapter 2, source code. Now it doesn't have the program 2_14, but look at this one. This is the resulting file name. Okay, so code blocks, chapter 4, source code. Now we see program 2_14, and then underneath that we're going to create a file called program 2_14.cbp, and that's what we want. And then this is the important stuff again, as we pointed out last time, the debug. We want that, and that'll allow us to step through the code. So we'll finish that, and we see all this directory structure set up over here. And then if we look in our folder, we see a main, we see the program 2_14.cbp that we were going to create. It's right where we expected it. Now if we do the twisty over here, we're going to see this main show up. Well, main, let's go ahead and double click that, and that shows up. There's our hello world program. Well, we don't care about that, so we're going to ignore that. We're actually going to get rid of it. But the important thing is that we got to get this file 2_14.cbp. we have to get that into our project, and that's as simple as right mouse click and then add file to active project. We want the debug information. Just press OK, and there it is. It shows up now. Now we can get rid of, we'll right mouse click on main. We don't want that, so we can actually remove that file from our project, and it's gone. So we have our project set up the way we'd like it now. Now if you look back in the folder here, main is still showing up, but it's not included in this file here, which kind of keeps track of all the files and the structure of the project. So let's keep an eye on both things. Let's go ahead and build now. And we see that everything runs fine. So now we can execute it. And there we have the answer we would expect. Now I'd like to show you the debugger. The debug window is actually showing right now. You can look at the debug up here, just like you do the build. You can look at debug, and you can start the debugger right here. It has these same icons that are showing up on this toolbar here. I just as soon use this toolbar. And first thing that we want to do is we want to set a breakpoint. So let's get this build information out of our way so we can see more of the program. Let's put a breakpoint here, and all you do is left mouse click and a stop sign shows up, or a ball, depending if you can see whether that's round or rectangle. And then we just run the program and it'll stop at that point. Okay, we see that there's a little yellow arrow on the stop sign, meaning that code execution has stopped right there. If we look at the output window, that's over here, and nothing's showing up in the output window as yet because we have not executed this line 20 with this first C out. Now line 20 is going to give us, when we move to the next step, we're going to see that the ocean levels will rise, and then we're going to add 5 years. 5 years was calculated right here. That was done by multiplying yearly rise, which is 1.5 times 5, and that's the value will be in 5 years. So let's go ahead and step it once. And now if we look at our output window, we see the ocean levels will rise 7.5. So that's by executing this cout statement. So let's put another breakpoint down on this one, and then let's see what we can do with our variables. So let's execute the next line, and we move to 7 years. And what I'd like to do is see what 7 years is. So if we left mouse, double click, it shows you all the places in the program where 7 years shows up. If I right mouse click on 7 years, it'll allow me to do a bunch of things, but what I want to do is watch 7 years. So let's click on that, and the watch window opens up. We can see in the watch window the value that it has and that it's a double and the variable name. Now the fact that it's at 7.89 in big long decimal precision here most likely means that the thing is uninitialized, and in fact it's probably got a huge e to the plus 262, so it's a big wild number. This is what you would get for an uninitialized value, but what you would do is set it to 0 when you declare the variable, and we can avoid that. So let's execute. What we'll do is we'll actually come up with a value, because we'll multiply again yearly rise, which is 1.5 times 7. So let's execute one more line, and here we go. Now we have a value, a decent value in 10.5, or 10.5 in 7 years. Now you can see, look here, 10 years, which is the next variable there, it was not initialized and has a big huge number in it likewise. So let's do cout. We'll do the next cout here. This is the next instruction. We'll step, and then we see here, here's our ocean levels will rise, so 10.5. So that value is shown here for the 7 years. Okay, so why don't we do the same thing? We'll put a breakpoint on the 10-year cout, and we'll step it again. So next line, and we can look again at 10 years. It's already showing here. It's not initialized, so 10 times 1.5, we'd expect at least 15. So here we go. So there's your 10 years, 15, and then we'll cout that. We'll expect it in the output window, and there you go. The ocean levels will rise 15, and that's the extent of our program. So now let's talk about this program just a little bit. I'm sure you can at this point match it to the pseudocode, but one thing that's new here is this const. This is very important. People lose a lot of points over this. We're learning about const right now. So you label the variable const, you give the data type, sometimes it's integer, sometimes it's string, and then whatever the variable name is, it's in capitals. And if it's multiple words, you put underscores between the words, as opposed to a regular variable which uses camel case. So the first word is lowercase, the next word and all words past that start with uppercase. So make sure that you start using constants. And in fact, this would get graded off. The fact there's a 5 in here and a 7 though, and a 10, those would be marked off as numeric constants in the code. So what we would want is to see more constants showing up here to hold the value 5, 7, and 10. And those would be, in this particular case, what? The number of years. So the final section of the chapter 2 talks about hand tracing a program. Don't bother. Do the debugger like this. It's a lot better. Professional programmers, if they get a chance, they'll prefer to use a debugger. You can see what the variables are doing. You don't have to set up a hand table and fill it in by pencil. This is the better way. So you're learning the best here.